In this problem, we're being asked to determine whether the given series converges or diverges according to the divergence test or the nth term test. So what I'm going to go ahead and do is I'm going to take the limit as n goes to infinity of my general term, right? My general term here is 7 to the n plus 1 over 7 to the n plus 1. I'm now going to go ahead and do a bit of a rewrite so I can actually determine what this limit is going to equal. So here, I want to go ahead and split these terms up. So I go ahead and write 7 to the power of n over 7 to the power of n plus 1. That's the first term split up. And then the plus 1 gets its own denominator, 7 to the n plus 1. Okay, we're on the right track here. Limit n goes to infinity. Using our exponent properties, 7 to the power of n over 7 to the power of n plus 1, when you divide same base terms, you subtract their exponents. So in our case, this should be 7 to the power of n minus n plus 1, which would be n minus 1, which should come out to be negative 1. So all in all, we should get 7 to the power of negative 1, or 1 over 7. And our 1 over 7 to the n plus 1 stays as is. We could also break out a 7 and then leave it 7 times 7 to the n. That's not really going to matter to us because as we take this limit to infinity, the limit does not affect the 1 over 7. There's no n in 1 over 7, so the limit does not touch that. And then when you take the limit of 1 over 7 to the power of n plus 1, we see that the denominator grows faster than the numerator, right? So we would get 1 over something that is going towards 7 to the infinity, which pushes towards infinity itself, and 1 over infinity would push towards 0. So we would get 1 over 7 plus 0, or 1 over 7 for our limit. Now the fact that we know this limit is now not equal to 0 tells us that our original series, which was summation n equals 1 to infinity of 7 to the n plus 1 over 7 to the n plus 1 power, that this diverges according to the divergence test or nth term test. Okay, so we just make our claim. We showed all the work that proved that the limit was not equal to 0, and then according to our divergence test, that limit not being 0 means that the original series diverges. There we go.